Hello, this is Mr. Manley, and in this video we're going to look at using determinants to solve a system of equations. Yet another way of solving a system of equations. Maybe not the most efficient way, but it is an application of matrices and specifically of determinants to just start a student on the path to understanding that these do have some application. Again, here, not an application that we probably use to solve this one, but it's a starting point. Cramer's rule. I'm going to begin by finding the determinant of the coefficient matrix. So if I take all of the coefficients, like so, I give myself a 3x3 matrix. And I'm going to find the determinant of this matrix. So for a 3x3 matrix, I have this special method where I rewrite the first two columns, double check that I've copied those correctly, and then I find the diagonal products. So this is 20 times 4 is 80, and then I've got 5 times 5 times 5 negative, that's negative 125, and this diagonal here will be a plus 10. So that's 90 minus 125, call it negative 35, right? Then on the downward diagonals, it looks like I have a negative 125. And I have this diagonal is minus 20. And this diagonal is minus 40. 20 times 2 is 40, and it's negative. So it's minus 40. And summing that, I've got 125, 145, 185. So minus 185. And so the determinant is negative 185, the bottom number, minus the top number. So I'll be minus a negative 35, which will be plus 35. And that'll give me negative 150, right? That coefficient matrix, I'm just going to call that D. So I'm going to take that over here and say I've got D is equal to negative 150. Now in this problem, it says it's actually just asking me to find X. And I might show you X and maybe Y as well, just to help you along. But this is asking us to find X. So to find X, let me go to a general statement here that X is equal to D sub X over D. Now we know what D is. That was this determinant that we found here. So we have that D, no problem there. But what's this D sub X? That's new, but we know it's a D. It's a determinant, right? So it's some determinant for X, and it's going to be this determinant. I'm going to take the coefficient matrix, and I'm going to replace all of the X's with all of the solutions, if that makes sense. So I'm going to go the first row, or the first column I should say, instead of the X coefficients, I'm going to use the solution coefficients. And then I'm going to just use the coefficients as they're given. So I've got 1, 5, 5, those are for the Y's. I've got 4, negative 5, negative 5. Those are for the Z's. And I'm going to find this determinant. Give myself room here. Remember, we rewrite the first two columns, like so. And then we multiply on the diagonals. So 25 times 4 is 100. This one's going to come out to 0, because I've got a 0 there. and then I've got plus 15. So that'll be 115 up there. I've got a 0 in that diagonal. On this diagonal, I've got minus 25. And on here, I've got 20 times negative 3. That'll be minus 60, right? So that'll be negative 85. And I'm going to do the determinant, this determinant d sub x, is equal to negative 85 minus 115. And what will that be? That will be, put 85 there, that's 190, that's negative 200, right? I'm going to go negative 200. And that's d sub x. D sub x equal to negative 200. All right, now recall when I had written up here on the right side that x is equal to d sub x over d. And now I've got d sub x and I've got d. So x is equal to negative 200 over negative 150. And we could do a bunch of simplifying here right there. And then 5 goes into that 3 times, into that 4 times. So it looks like x is equal to 4 over 3. How about that? Well, one thing we could do is we could use another method and check it, right? Maybe we'll hold off and maybe look at that. But for right now, I want to go ahead and show you what if I were solving for y. Well, obviously, if x is d sub x over d, of course, y is going to be d sub y over d. So let's do that. And we already have d. It's going to be the same d. And I just need d sub y. So d sub y is going to be, and I'm going to set up this matrix. Here are my x's. And then my y values I'm going to replace with the solution because I want to know what y is. So I'm going to go 0, negative 3, 5. And then I'll have my z values. 4, negative 5, negative 5. And then I would find that determinant. Through the same method, repeat the column, use the diagonals. I'm not going to go through that, but I just wanted to show you how you set it up if you wanted to solve for y using this Cramer's rule.